Hello everybody, back again, part 3 of this section of notes over simplex method for solving a system of inequalities. Here we go. First things first, again, the baby steps. You'll want to first rewrite your I system as an E system. So here are the equations for the E system. Again, we add slack variables to any of the constraints that we have, and we don't worry about the non-negative constraints. And lastly, again, you want to make sure that in your optimization equation or objective function, you want to make sure that the variable that's here, it's either P or C or whatever is not x sub 1, x sub 2, or x and y. You want to make sure that that is positive in your equation. So again, you'll be subtracting these terms to the left side of the equation. Once you have your E system, you want to set up the simplex tableau. So here's the simplex tableau. Again, you want to make sure you have the slack variable 1 equation first. It's this one. The slack variable 2 equation next. It's this one. And then your objective function will always be the last row. All right, let's go through and find the pivot position next. The pivot position, again, is based on the most negative number in the bottom row. In this case is this 5. So that is where the column is, the pivot column is. All right, so pivot column is this whole thing here. Very good. Now, in order to find the pivot position, remember, you have to divide the last element in each row, so in this case 6, by the element in that column, 1. So 6 divided by 1 is 6, and you do that for every row except for the last one. 4 divided by 1 is 4. You pick the smaller number, and then you find out that this is where the pivot element is. From this point, once you have the pivot element, you want to turn it into a 1, which we have yet to deal with here in this set of notes. It's already a 1, so we don't have to worry about it so much. But then what we need to do is once this pivot element is a 1, we have to get zeros above and below. So that requires 2 different row operations here. And to get zeros, of course, we will be using a row combination. And what that means is we will be taking S sub 2, which is where our 1 is, that we're trying to keep a 1. We have to multiply it by the opposite of the number in the row S sub 1. So the opposite of 1 is negative 1. We will add it to S sub 1, and then we will take that result and replace S sub 1. And then we'll do something very similar for P, because we need to get a 0 down here as well. So we will take 5 times S sub 2, because 5 is the opposite of where we want the 0 here. 5 is the opposite of negative 5. We will add it to row P, and we will put that result in row P. So I'll write out the row operations down here. Try them for yourself real quick, but I'll come back in about 5 seconds with those operations here. So here are the new rows for S1 and P. So what do? We take this matrix, the simplex tableau, and we write another one with this new row for S1 and this new row for P. Right about there. So when I write out this new matrix with these new rows in it, it'll look something like, I know S sub 2 hasn't changed, so it's 1, 1, 0, 1, 0, 4. The first row changed, 0, -1, -1, 1, 0, -2, and the last row changed. What do we have? 0, 2, 0, 5, 1, and 20. So x sub 1, x sub 2, s sub 1, s sub 2, and p. Now again, as what happened in the last example, you'll notice that x sub 1 is the column 0, 1, 0. And this column here used to be right here in s sub 2. I realize I'm making a mistake here. There we go. So s sub 1, we have a new s sub 1. So this column used to be here. It shifted from s sub 2, quote unquote shifted from s sub 2 to be under x sub 1. So this new row label is x sub 1 because it used to be here. Oops. And now it's here. So that means s sub 2 exited and x sub 1 entered. All right. So again, if this problem were to continue anymore, we would have to look for the next negative number in this bottom row. There is no next negative number in this bottom row. So this example, we're done. So how do you get your answer together? Well, you'll notice again that the last column will tell you the values of these three variables on the left. So s sub 1 is -2, and again, that doesn't make any sense, as you know from the table method. X sub 1 will equal 4, and P will equal 20. So if you go back and remember the optimization equation back up here, you know x sub 1, what was it? 5 times x sub 1 plus 3 times x sub 2 equals the profit. Well, if x sub 1 is 4, and we don't have a value for x sub 2, that just means it ends up being 0. If you substitute those values into this equation here, it'll be 5 times 4 plus 3 times 0 is 20, just like we said it was going to be. So 4 units of whatever x sub 1 is will maximize our profit here. All right, that takes care of this particular video or this example. The next couple examples, I think I'm going to shove into one video, so it's going to be a little bit of a longer video, but it'll go over exactly what I was saying. If you perform these row operations and you still have a negative down here in the bottom row afterward, we will go over how to wrestle with that to get a final answer. Until next time, I hope this made sense. I hope you have a better understanding of the simplex method, and good luck, everybody.